Hello everyone, in this video I'm going to discuss the example for function and graph. Kindly refers to the question, a function of f is given by the fx is equals to x squared minus 2x minus 3. Refers to the question A, is the function fx a one-to-one function? So in here we have two methods. Method number one, by using graphical method. Second method will be algebraic method. So let's begin with the graphical method. First, what we have to do is to sketch the graph. In order to sketch the graph, there are following steps. Step number one, the shape. By referring to the function, we have the x squared minus 2x minus 3, referring to the coefficient for x squared. So in here we have 1x squared, a greater than 0. So the shape will be the U shape. Second step is to find the intersection. So here we have the x-intercept and also the y-intercept. How to find the x-intercept? When y is equal to 0. So kindly substitute. So here we have 0 is equals to x squared minus 2x minus 3. We have to factorize the situation. So x minus 3 bracket x plus with the 1 equals to 0. X is equals to 3, x is equals to negative 1. So we have the x-intercept, which is 3, 0, negative 1, 0. Continue. Next is to find the y-intercept when x is equals to 0. So y is equals to 0 squared minus 0 multiplied with the negative 2, and then we have minus 3. So y is equals to negative 3. So the coordinate for y-intercept will be 0, negative 3. Continue. We have to find the standard form. Focus on the situation. We have the fx is equals to x squared minus 2x minus 3. In order to find the standard form, we have to completing the square. Before we start completing the square, make sure that we have the x squared with the coefficient 1, positive 1. So in here we have the positive 1. Continue. We have x squared minus 2x plus bracket square minus bracket square minus 3. In order to completing the square, we have to refer to the negative 2 or the coefficient for x. We have the negative 2 divided by 2. Continue, negative 1. Because if we simplify negative 2 over 2, we will have negative 1. Next, x minus 1 due to this part. Continue, we have negative 1, negative 3, so we will have negative 4. So that will be the standard form for the function fx. Continue, refers to the shape, we have the union shape or the U shape. Continue, refers to the shape, we have the U shape. So in here we will have the minimum point. The minimum point would be 1, negative 4. And the symmetrical axis, it will be x is equals to 1. Next, continue with the graph. So kindly plot the situation. Number 1, we have the shape U shape. Number 2, we have the x-intercept where we have 3, 0 and negative 1, 0. 3, 0, 1, 2, 3, negative 1, 0. So here we have the coordinate for the x-intercept. Continue, we have y-intercept 0, negative 3. Next, refers to the standard form, we have the minimum point 1, negative 4. So here will be the location. So kindly sketch the graph. So here we have the U-shaped graph or the function for fx is equals to x squared minus 2x minus 3. Kindly refers to the question, is the fx a one-to-one function? By referring to the graph, we have the U shape, then make use of the horizontal line test. So let's draw the horizontal line. So in here we have the line. So if it refers to the situation, here we have two intersection points. Then we can say fx is not one-to-one function because it cuts more than 1 point. So that is the statement and also the reason. Continue. State the domain in which the fx is one-to-one. So due to the situation, we have to close up one part of the function or one part of the graph. Then only we can avoid the situation cut more than 1 point. Example refers to this part. The highlighted part only have one intersection between the horizontal line. So that will be the domain. Or, refers to the another part, domain for f would be negative infinity until 1. Or our answer would be from the 1 until positive infinity. Then we can say the function of fx is one-to-one function. So for this case, I prefer that we choose the positive side to become the one-to-one function or the domain for one-to-one function. Next, we have the algebraic method. So kindly refers to the question, and previously we already completing the square, where we have the function fx is equals to x squared minus 2x minus 3. Actually, it's the same as fx is equals to bracket x minus 1 bracket square minus 4. So we have the standard form and also the general form. So by using the algebraic method, we have to make sure the situation must be begins with the standard form. So let's begin. F bracket x sub 1 is equals to f bracket x sub 2. Continue, substitute the situation. We have the bracket x sub 1 minus 1 bracket square minus 4 on the left equals to bracket x sub 2 minus 1 squared minus 4 on the right. Kindly rearrange the situation, or we can say simplify. So we will have x sub 1 minus 1 bracket square is equals to x square minus 1 bracket square. Continue. We have x sub 1 minus 1 is equals to square root of, we have the square root plus minus bracket x sub 2 minus 1 bracket square. Finally, x sub 1 is equals to plus minus, we have the square root bracket x sub 2 minus 1 bracket square plus with the 1. So by referring to the situation, we notice that x sub 1 is not equals to x sub 2. So in here, we can say fx is not one-to-one function. So that is the answer for the question A, for the algebraic method. Next, refers to the question B. State the domain in which the function fx is one-to-one function. In order to get one-to-one function, we need to refer to the standard form. By referring to the maximum or minimum point or the symmetrical axis for the standard form in here, we have the minimum point, which is 1, negative 4. We have the symmetrical axis, which is x is equals to 1. By referring to the graph on the right-hand side, we notice that if we are using the horizontal line test, it will intersect or cut the graph for 2 points or more than 1 point. So in order to avoid the situation, meaning that must only have 1 point, then we have to close up part of the graph, which is the referring to the symmetrical axis. So x is equals to 1. Either we choose the left-hand side of the graph or the right-hand side for the graph. So by referring to the graph, either we choose the left-hand side of the symmetrical axis or we choose the right-hand side of the symmetrical axis. Then only the graph will become one-to-one function. So that is the graphical method. If you are dealing with the algebraic method, we only can refer to the symmetrical axis, or we can say the minimum point. So in here, we have the situation, domain for the function f, in order to become the one-to-one function, we will be 1 until infinity. By referring to the symmetrical axis, we choose the right-hand side. Or we can choose the left-hand side, negative infinity until 1. So which means that on the left-hand side. So for this question, I prefer to choose the right-hand side. And the answer will be, if the domain is 1 until infinity, then the function of fx will be one-to-one function. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.